Hi coders, CS Time channel here, and this video discuss about stack operation with linked list implementation. Let's see the first operation, push operation. Suppose you are given an element A to push into a stack. We understand from the explanation that insertion and deletion, or push and pop, can be performed only at one end, that is called top. So at first, we will initialize top with null. And when we enter the element into a stack, it will look like this. Top point to the null, and then we enter an element A. Once we enter A element, then now we have to adjust the top to point to the new element, which is A. So now, top point to the A. And if you want to add another element, then the latest element will place on top of A element. For example, I want to add B, then B will be placed on top of A. And the top pointer should be adjusted to point to B because the top position now is B. The same process happens as we add another element. So our stack now look like this. Let's see the Java implementation. So we will implement how to do the push operation here. But before that, we need to declare the top. Here, I will declare it using linked list because our implementation is in linked list. And then I will also declare the size of the stack like that. Now I will create the class for the linked list. The linked list will consist of data as well as the pointer. So I will have to declare the data character, and I will declare also the pointer using linked list. Now create the constructor for list node, and then initialize the data with the data this one, and then I initialize the pointer next with null. Now I will create the constructor for the class. So initialize the top with null because I want the top point to the null in the beginning, and then we initialize the length with 0. And to know the size of the stack, create the method for the length. So I will declare it as public integer length. Then it means we will just return length. And then another method that I need is to check whether our stack is empty or not. I will declare it as boolean. We will just return true or false here by checking the size of the stack. So when the size of the stack equal to 0, it will return true, empty. But when the size is not equal to 0, it will return false. Now the push method, when we want to push, we need the data. Here, my data is character data. And then we have to create the node for the data. I create the node first. Say I use temp, new list node. And then we will just enter this data. So when we push the node, which is temp here, we want to adjust its pointer to point to top. After we create the node, then we will push this node into the stack, and when we push it into the stack, we want to adjust its pointer to point to the top. So temp.next will point to the top, and then top will point to the temp. Then we increase the size of the stack. The second operation is pop operation. The same as push operation, pop operation also happen at the same end. So the first element to be popped, or the first element to be deleted, is the element that pointed by top. So when we delete D like this, then we will have to adjust the pointer of the top like this. And then again, after we deleted C, then the pointer of the top need to be adjusted. Let's see the Java implementation. We will write our pop method. So before we delete an element from the stack, we will check first if the stack is empty to avoid error. So we will just call the isEmpty method here. If it's yes empty, we can give a message, or you can also throw an exception, empty stack exception. To use this, we can import stack exception. But if it's not empty, then we will hold the top data to a variable. Say I use delete variable to hold the top data, and then I adjust the position of the top. Top is top.next. so that it point to the following element. And then I also reduce the size of the stack by 1, and then I return the element that I deleted. Now let's see the third operation is pick. This is just to read the element of the stack without deleting it. So we can only read the top of the element, or we can also read the whole element. We understand that the top pointer will always point the top element. Then we can just return the D element, or we can pick all the element from top to the next, to the next, to the next. Let's see the Java implementation. To write the pick method, we will just return the character if we want to read only the top element of the stack. So at first we need to check if our stack is empty by calling the isEmpty method. If it's yes, we will just copy this and then place it there. If it's not empty, since we want to read only the top element, we can just return top.data. However, if you want to read all element of the stack, we can create another method here. I will name it with pick2. Then again, we will check if it's empty or not. I will just copy. If it's not empty, then I need one pointer that point to top. Here, I will use current that I will declare it as linked list. And then I assign it to point to top. Now we will tell the current to pick or read the stack from the top until the end. So while current not equal to null, then we will display the current data. And then we tell the current to move to the next node. On the main method, at first we will create the object for the stack class. Stack as equal to new stack. Let's push A, B, C, D for examples. Now if you want to pick, we can just call pick here. If you want to pick only one, then we can call it as dot pick. Then it will display the one on top. Let's run it. As we can see here, the first thing we push is A, so A is at the bottom, and then B on top of A, C on top of B, and then D on the very top, so we get the one on very top. That's the pick. But if we want to pick all of the element, then we can call 2. So we will call pick 2 here. Okay, we'll see. So this is the first one from pick 1, and then this is from pick 2. We push A, so A at the very bottom, on top of it B, on top of it C, and then on top of it D. So D, after D, C, and then B, and then A. Let's check our pop method now. Say for example, I want to pop on the one very top. Then let's see if I call again pick, what will be on top. Okay, you see here. So this D come from calling this, and then D, C, B, A come from calling this, and then after that we delete it. We don't display what we deleted, and we want to know whether it's already deleted or not, calling as pick. So now the one on the very top is C, so it means D has been deleted. If you learned something from this video, please subscribe and like for more videos. Thanks for watching.